Hi, everyone. It's Judy here from South Africa. And I can see that everybody's coming into our webinar, and really great to see a number of you here today. So we are expecting in the region of 20 people. So if we can just give it one more minute, and then we'll be able to begin. Great. I think we're going to start. So welcome to everybody, and to our session where we're going to be covering our suborbital rocket challenge for 2022, partnership between bluShift Aerospace and MaxIQ Space. So yes, in this information session, what we're going to be doing is covering the rollout plan, a very high level rollout plan as we have it at the moment. And so what I would like to suggest is, please, if you have any questions, please put them into the Q&A. Also, the chat is open. So if you just want to introduce who you are and where you're from, that would also really be amazing, because what we'll find is we're all going to be working together quite a lot as we go forward. So before I actually start, I was wondering, are there any questions, or is there anything that you really want me to cover before the end of the session? Okay, and I'm quite happy if you want to raise your hand, and we don't have to stick to this this webinar format. I'm very happy to promote people to be panelists if you want to share anything with the group. So I'm very happy to do that. Great. Okay, so if there aren't any questions to begin with, what I can do is I can get straight into it. So let me share my screen again. Here we go. So the way we're going to roll it out is we've got 3 stages, and a number of you already have X-in-a-Box kits. A number of you have been working with the X chips and the X-in-a-Box kits for some years now, dating all the way back to when the first kits we ever delivered were for the ThinSat program. And so for phase 1A and phase 1B. So that's why a number of you have kits already. Some of you met us along the way, and so you've also got some X-in-a-Box kits that you've been implementing in your classrooms, in your institutions as well. However, there's also a number of you who've never actually held an X chip in your hands. So what we're going to be doing is that during February, for those of you who signed up and have absolutely no experience with these modular electronics, what we're going to be doing is we're going to be sending you some kits, and we're going to have a getting started program. So this is actually the kit. This is the kit that I've connected. This is version 1.5 of the X chips that Bianca's designed. So what it is it has a slightly different core on it. Your X chips will work. Okay, they will always still work. And what we'll do is we'll make sure that during the Getting Started program, we can take you through the latest versions of the code for the X chips, so that what you can do is you can flash with that. But the thing is that what we have over here is this code is quite nice because it also has quite a lot of graphics. I mean, I don't know if you can see it. I don't know if what the screen is doing on your side, but so we have a weather sensor giving us temperature and relative humidity. We've got the light sensor with visible light and UV index. And then I haven't got it connected here. That's why it's got a big cross through it. It's actually a soil moisture sensor. So the soil moisture sensor I've actually got connected in a pot plant that I have in another room. And then what we have is we have this bluShift chip. What we've done is we've done the mechanical blank as a bluShift chip. So it hasn't got a sensor on it, but what it has got though is it still connects communication, I2C, as well as power. And on the back is a QR code. So the thing is, when you scan that QR code, what it'll do is it'll take you to a web page that we're developing with all the materials, the getting started guide, tips and tricks, and all the content you're going to need for the program. So everybody's going to be getting bluShift chips anyway. That is also why when you signed up, even if your participation was actually being sponsored by another organization or by somebody else or something like that, we still needed you to sign up. It's because what we need to address, because we need to get kits to you. So what we're going to be doing is we'll be sending out a number of these starter kits. And then what we'll do is we'll go through 4 sessions. We'll have 4 Zoom workshops, and we'll all agree a time that really works. They'll also be recorded. And we'll go through 4 different experiments so that you and your students and your teammates can get really used to working with the chips, with the modular electronics. How does it work? And really getting very au fait and very, very comfortable with it. So I'm just wondering, what I'm going to do is I'm going to quickly have a look at the chat, and I'm going to see here if there's any questions. I think it's everybody introducing themselves from all over the place. It's absolutely wonderful. We've got a number of participants from the USA, and a number of institutions who are completely new to the ecosystem of these modular electronics. And we also have a number of teams from South Africa as well as from Senegal. So we have a university in Senegal that is going to be participating. So yes, so we have this first phase, and then what it is that the really big deep part of this program is going to be here, the second phase, which is in the bluShift Blue. And here we're going to be developing our solutions for our launch. So a number of you already have your kits, your advanced kits, in terms of the XK90 CubeSat kits, or otherwise the XK07 high altitude balloon or advanced sensing kit. And for those of you who don't, we're going to be sending you flight hardware so that you can actually start building your payloads. And that will be, so this phase will run from March till the end of June. And we'll have a number of workshops, virtual workshops and presentations, and there'll be 18 sessions. We've worked out that there's going to be, we've got time for 18 really great sessions, also taking into consideration that there are going to be some holidays in between, there are going to be some breaks and things like that, that we need to accommodate. And then, of course, it's our suborbital flight. All of the kits are going to be shipped to us at MaxIQ for integration. We're going to make sure that everything is tested and everything's working. And then what we do is we send everything off to bluShift Aerospace. They put it on their rocket in their payload bay, and their intention is to return the kits to everybody, because they need to recover their rockets. So they have full intention of getting the kits back to us. So let's have a look at a little bit more detail. I covered this a little bit earlier in terms of the activities. We'll get the kits to you. We'll have an onboarding workshop with support content. We'll learn about light, and we'll run an experiment with the light sensor, visible light, UV, etc. Understanding comfort levels, a workshop and an experiment. And then what we'll do is, using the soil moisture sensor, actually design an experiment and implement it. So you can pick a topic, or otherwise you can use any of the other sensors if you wish to. And what you can do is the team can pick a topic, so that what you can do is you can really design your experiment and design your research, take it from right from concept all the way through. So what this introductory getting started part of the program is we're also going to be covering understanding modular electronics and Internet of Things. We're going to look at data collection and analysis, as well as working with digital dashboards and remote sensing, because these are very important skills, and it's a very important foundation that we're going to need to go on to our next step, where we're developing solutions with the kits that we already have. So I see that there's a question, so I'm quickly going to go there. Okay, so Vincent. Vincent, I know that in terms of your kits that you already have from X in a Box, you have got the XK90 CubeSat kits. So what you'll be able to do is you will be able to use those components because everything is compatible. We've made absolutely sure of that. So you have, I know that you have the GPS, you have your IMU with your accelerometer, gyroscope, and magnetometer. You also have the gas sensor, the SG33, which gives you volatile organic compounds and carbon dioxide equivalent, which could be very, very useful since the rocket is going to be fueled with a biofuel. So we may actually want to be able to test. We may want to be able to test carbon dioxide and volatile organics. And Cody, I see that you've asked a question. If you don't mind, I'd prefer to keep that to the end. But just to get back to conclude for Vincent, Vincent, we're not going to have any additional sensors for this program over and above what you already have. The light sensor, the weather sensor, the GPS, IMU, and the gas sensor. So we're gonna stick to that repertoire for now. I don't think any of you are going to be putting your soil moisture sensor on the rocket, but you never know. Maybe there's a group who wants to see what happens to soil moisture in our 6 minutes of weightlessness. So certainly we could be looking at that. What I'd like to do is I quickly want to just stop sharing so that what I'm going to do is that now that we have Cody with us, Cody had to rush out of his education, so I'm gonna be promoting Cody so that he can assist me along the way with the Q&A and all of that kind of thing. Cody, welcome.
Hello.
I'm very pleased.
I apologize for my delay.
No, please. It's all in the good cause. So that's wonderful. Absolutely wonderful. Thank you so much. Ah, it looks cold there. Look at me. I'm going to make you jealous. I'm in a t-shirt. I'm going to make you jealous.
I can come visit sometime if you want. I'd be happy to.
Excellent. Great. Wonderful. So here we go. Let's just go back to what are we going to be doing during the main phase of our program. And Daniel Lee from New Jersey is absolutely key to this. Cody, I'm not sure if you can see Daniel there, and if you wouldn't mind, maybe what you can do is maybe you can also promote him to a panelist. I hope we're not bulldozing your day, Daniel. And so what we're going to be doing is that the main part of our program, we're going to be basing on this character here, C3PO. And how exactly are we going to be doing that? Those 18 weeks of, it's going to be one workshop a week of virtual workshops are going to be covering the C3 Ps and O of satellite design. So we're going to look at communication, payload, power, propulsion, operations. Really, I'm sorry, I have to apologize for this slide. The slide is terrible. It's way too busy. When I learned about PowerPoint, what was it, like 20, 25 years ago, I was told that you never put more on a slide than you would print on a t-shirt. So this would make for a really awful t-shirt. I must apologize for this. Yeah, so in addition to the C3PO, 3Ps and the O topics, we will be delivering the program using systems engineering concepts and techniques. So we're going to have that as our theme throughout the program. We'll also have topic-related guest speakers from the space industry to share how the learning is applied in the industry itself, and also to answer some career-related questions. We have a number of school students who are on the program, and so they're going to be very, very interested in how can they actually start participating in the industry in terms of their careers. And all workshops will be virtual and live, and they'll also be recorded so that they can be available to all the participants. And I'm very happy, and I'm offering that what we do is during the week between the workshops, I'm very happy to have some unstructured informal catch-up sessions, because maybe what it is maybe you want to be able to take a particular concept and then apply it in your classroom, because maybe you want to take your students through it, or maybe perhaps you've got for example, maybe at the Challenger Center or the main Discovery Museum, maybe you've got groups of students coming in and you want to maybe design some kind of engagement with them for that week around that topic, or whatever it may be. Let's certainly discuss that. We're also very aware that we've got some universities who are participating, and when you look at this, you think, oh my heavens, this is going to be so childish. It's not mandatory that these workshops are attended at all. What it is that we really want to be able to share as much knowledge and as much information as possible during the period. So for those of you who have already built satellites and who already launched satellites and things like that, don't worry. We don't want to hold you back. Go for it. What would be nice is if you see some of these topics and you think, wow, I've really got something to share, and I've got some experience to share and some knowledge to share. We would love you to put your hands up and say, I'd love to deliver that session for you. So that people don't get bored listening to my Johannesburg, South African accent. That is C3PO. So we're going to be seeing a little bit of this guy. And and so then what's going to happen is we're going to get to the time of our suborbital flight. As I mentioned earlier, the kits are going to be shipped to MaxIQ for integration. So then we're going to have the launch with bluShift, and the kits are going to be returned. So a little bit about, I've had some questions as well, is if it's a challenge, does it mean that everybody actually gets to go on the launch who's signed up? Yes, everybody gets to go on the launch, because the reward for this challenge comes afterwards, comes later. bluShift Aerospace are developing a rocket and a mechanism where you're going to be able to launch your CubeSat into orbit, and because of their design and because of their business model, really you're going to be able to pick to a degree your altitude as well as your inclination, and that is what really makes this so attractive to everybody around the world, because most of us, especially on if we north and south of the tropics, we really would prefer to have a polar orbit. Some of us would like to have a sun synchronous orbit. So The challenge is to achieve the mission as designed. So what you will do is through the program, when you design your payload and you design your mission, what you'll do is you'll articulate that. This is what we want to achieve, and let's make sure that we have achieved that. To analyze the data once you receive your kit back, and suggest how to scale to an orbital mission. Presentations, we'll have presentations during World Space Week. All the participants in the challenge who are wanting to keep going with the challenge will present during World Space Week, which is always from the 4th to the 11th of October. And then we'll have our orbital launches for the top 3 submissions. The plan, I believe, and please somebody from bluShift Aerospace correct me because I probably got it wrong, but we're looking at, let's say, 2024, 2025 for orbital launches. And throughout this whole program, please, I'd like everybody to remember that space is hard. There could be delays, and it's a rocket test for bluShift, and it's a proof of concept for the rest of us. So we're all going to be making mistakes. We're all going to be repeating ourselves, and we're all going to be improving. And that is also why we want to have this long period here in the middle. We want to have these 18 weeks so that you can test your payload on model rockets. Cody is setting up with, in terms of you being able to design your own model rockets or procure them. He set up specialists who can help with all of that, so that you can test your payloads and you can improve things and you can break them and get them replaced by us before you go on your suborbital flight. So with that, I'm going to take a breath. And Cody, let's go through and see if we have any questions.
Sure, absolutely. Let's see. I see Sasha here did confirm that the first orbital flight is projected 2024 to 2025. So you were correct, Judy.
Oh wow! Okay, that's
Wonderful.
cool. I'm gonna.
And then it seems we have a gentleman named Fred here is wondering if there will be an interface control document available, and they may want to fly their charged particle detector, if possible.
Okay. Yes, Fred Bruvader. Thank you. Yes, absolutely. Fred, there is. We are working on that, and our feet are being kept to the coals by Mike Galvin, who is also here from Princeton in New Jersey. And because thanks to Mike, all of our feet were very close to the coals during the ThinSat program. So we're definitely working on that. And Fred's also asking you, Cody, where's your bow tie? Like, well, what's going on?
I didn't have time to get all the nice clothes. This is not PJs. This is a Starship hoodie, okay? And listen, if the bluShift boys want to send me a Starless Road hoodie, I'll wear that next time. But
that's great.
In the meantime, it's a Starship. Absolutely.
And Fred, absolutely, we would really like it if you could fly your sensor. I think what we should do is let's set up a session with bluShift, because I know that you're going to have some special requirements for that. So let's just make sure that we can do that. Great. Cody, next question.
Next question, moving on. From Vincent, he says, in our CubeSat challenge with the U.S. Department of Energy, we had different ideas for our payload. We wanted to use an infrared camera, possible.
Okay. Department of Education. Department of
Energy.
Oh, no, education. Don't worry, it's okay.
Okay, I apologize.
It's probably autocorrect. So that's these things happen. So yeah, Vincent's group school was one of the 5 winners, one could say, of the CTE CubeSat Challenge in 2020. And so they received CubeSat kits from us. At the time, we weren't ready with the code for the infrared sensor. So, and Daniel Lee, I'm not sure if you're around. I know that what happened was that Daniel's school in Montgomery, what they did is they actually purchased some of the sensors that were used on the ThinSat program, the space flight hardware. They purchased some of those infrared sensors. And Daniel, I'm not sure if you were able to do the code and get it working with your CubeSat kit. So definitely we should be able to look at that. I think that with this particular launch, the suborbital launch, because we're not going to be exposed, well, let's actually see how much exposure we're able to get to space in terms of flying those infrared sensors. But I do know that we can probably get hold of some. I don't think all of them were used up by Virginia Space. So I'm fairly confident that what we can do is we can recover some of those sensors from them to use on this mission. Let's see if they work. It would be great. It's always worth a try. Yeah, it's always worth a try.
We have another question in the comments. Is building the payload part of the program? Short answer, yes.
Yes, absolutely. Absolutely.
Also,
yeah,
based off payload design too. So based off of the array of chips, you'll be able to choose what you want your payload to be investigating, if you will, what kind of data you'd like to be collecting. So that's the major part of the program, I'd say, necessarily. And then, of course, the technical knowledge that your students will gain throughout the whole process as well. Let's see if we got anything else. I think that may be it for now. Yeah, I think so. Also, too, if everyone wants to throw their questions, there's a Q&A button that's different than the chat box. That'll just keep it kind of separated. That way nothing gets lost in the comments or anything.
Okay.
I think that's it for now, though.
Okay.
Yeah.
Well, I think what we're going to do, I mean, Cody, you and I we'll hang around for a while.
Sure,
if there are any more questions.
I'll put mine and Judy's email in the chat, and if anybody thinks of anything after this or later on tonight or throughout the week, whenever, just send us an email too, and I'm sure we'll definitely get you an answer promptly.
Yeah, absolutely. Definitely. So what we're doing is the manifest is open until the end of this month, and for participating teams to sign up. If you would like to reserve a space, just let us know, and we can reserve a space for you on the manifest. If you may be in a situation where perhaps you want to raise some budget for it, but you haven't secured that budget or whatever, that's absolutely fine. We'll still keep your space available for you. And there's no, if you need to cancel for some reason, there's absolutely no penalty for that whatsoever. It's we're not like that. For us, it's all about education and outreach and engaging and learning a lot and having a lot of fun while we do it. So yeah.
Actually, we're getting some more questions in here too, Judy.
Great.
So another one from Fred says, we are planning on flying a high altitude balloon, hopefully this semester. Is flying payload on a model rocket a requirement? And this relates to his first question. How does it affect what we do? I don't think so. The whole point of the model rockets is to give your students like a first test to see almost like another set of data points where they can compare, their initial at-home experience, if you will, to the actual suborbital launch. So, I mean, if you choose to do weather balloon, that's totally great. I'd love variety. That's the other thing that I'm trying to push with the whole model rocket challenge is that I'm working with distributors who are going to manufacture our own custom MaxIQ rockets. We're going to encourage people to 3D print their own rockets. If you want to go buy your own model rocket that you found off the internet, totally fine. Did I put my address in the chat? I don't see it. The email address, yeah, I believe I did. Sorry, I got off topic there. Yeah, but we're trying to encourage all different types though. So yeah, weather balloons are definitely cut it for sure.
Yeah, absolutely. And Fred, definitely. Please let us know when you want to do that, because maybe what you want to do is maybe you also want to fly some of the new flight hardware that Bianca's designing at the moment. So we're very happy to send you some of that.
The email should be in the chat now. I apologize, everybody. Oh yeah, we're getting questions after. Here we go. Could we please list the sensors that these kits will have?
Okay.
Possible.
Absolutely. So what I can do, sorry, Cody, let me just have a look. Who was that question from?
Dominique Evans.
Okay, Dominique. It's all the sensors that you have in your X in a box kits. So we're not adding anything different. We're not planning to add anything extra from the ones you already have at the moment, which is the weather sensor, the light sensor, gas sensor, IMU, GPS. Yeah, I mean, so some of you may actually want to test out the radios. We're still confirming with bluShift Aerospace what kind of communication downlink we're going to have during the flight. So our intention is that we all, with all of our payloads, that what we do is we save the data on the SD card, but also the thing is that on Sunday, when Sasha took us on the tour of the site, of the test site, he did mention that we're going to have a data downlink, in case there's some kind of failure, which of course we all really, really hope there isn't going to be. But we are going to have redundancy in terms of being able to have access to our data during the flight. But the thing is, I mean, some of you may actually want to try the LoRa radios or something like that. What we're doing is that we're most likely going to be sending you a replacement GPS unit, the SM01, and what it has is it actually has a detachable antenna, so that what you can do is that you can actually, perhaps we can have that outside, or we can do something like that. But let's see how that goes. But yeah. We're not adding ourselves. We're not adding any more sensors or any more complexity to it right now, unless you have your own sensors that you want to fly. That's absolutely fine. A number of people have mentioned they want to fly their own sensors. That's cool.
Absolutely. And then we have two questions that are actually kind of similar. Another one from Dominique and one from Susie Cunningham. Dominique asked, what is the cost for an orbital launch? And then Susie asked, how much will this cost a school? Something I definitely want to make sure everyone understands. This first launch that we're talking about right now is going to be suborbital. So
yes, the
price for this launch is going to be considerably different than the actual orbital launch. I'm not sure if we have that exact price on yet, Judy, if you do not.
You know what? I have actually received quotes from bluShift Aerospace, and I have actually reserved payload volume on those flights. However, that was probably about 6 months ago, so I do not have it off the top of my head. Okay, but
we can definitely,
so what I can do is let me go back to that and let me find that. It's very reasonable, the pricing that I've got from bluShift Aerospace. It's like dramatically lower than a number of the other players who would be quoting you at the moment. So let me get back to you on that. I'm so sorry, I don't have it at the top of my head.
Okay. And then just to answer Susie's question, I think for the current program, it's currently $1,500 for a kit plus the slot on the launch.
Yeah, but I think that, you know, for those, a number of the people in the session tonight already have all of the X chips that they would need for it. So then it's $995.
Right, for the
for participation. Launches. Yeah, because we don't need to provide the kits.
Wonderful.
Yeah.
But yeah, that's actually a huge point too for the schools that are going to be staying with us for a while here. You can reuse your kits if your students don't end up taking them with us. If they stay with the schools can reuse the kits, and then your only fees will be the launch fee year over year. So.
Yeah, Cody, that's actually a very, very good point you make, because we have schools who received kits in 2017 who are still using them. It's going to be now the 5th or 6th year in a row that they're using exactly the same kit. So yeah, it's all reusable. The only irrecoverable cost is that cost of the launch. Yeah.
And Dominic, you can definitely get a copy of the recording. We can definitely make sure that it's sent
definitely.
Your way, for sure. Vincent has a question. He says, we've been working with the Raspberry Pi interface with visible cameras. Does this mean that we cannot use such microcontrollers in the launch on August 2022?
Please, definitely you can, Vincent. Absolutely, not a problem at all. In a way, we actually encourage it because the more variety, the better. So definitely, if you want to do that, that's not a problem.
And then I think we have a question from Seth from bluShift Aerospace, if I'm not mistaken here. He says, for the teams participating for the first time or thinking about it, do most schools work these missions into their STEM curriculum, or is it more often done as an extracurricular or a curriculum resource on the side? And I think it's kind of both now, right? Because I know of some schools who are looking at picking it up for 2022 who have also integrated an entire like a 4-year technology plan in their high school. And I know that they're considering they'll be trying it out this year. And if it goes well, then they may very well be integrating it into their core lesson plan. So I think it goes both ways, actually. It's really up to the school and the best way that they think that they could fit the material in, or the most beneficial way, or the most amount of kids too that they get exposure to.
Yeah, absolutely. Especially this first time that we're doing it. So Seth, I know that your plan is to keep doing the suborbital launches, and anywhere between 6 or 8 launches a year, suborbital launches. So what we're doing is that this year we're using the program as well to build curriculum and to build lesson plans and things like that, so that next year and next time around, what we can do is we can actually provide that, so that then the teachers can take it and then they can just customize it a little bit. We've also been one of our team members and great contributors has also suggested that maybe what we do is maybe we provide a service where we really assist with that integration process and customization process. So that could also be something that we could definitely look at next year. But I think for now, Cody, you're absolutely right, because I know that you've been in conversation with 1 or 2 schools where they actually are going to be building it into their plan. And we also have a number of schools where it's a special interest group who are doing it as an extracurricular subject. Seth, I hope that answers the question. And Cassie is saying, I'm the STEM instructional specialist at the elementary school. So I implemented into my course the entire year and have started to train our teachers to utilize them within their classes. Yeah, that's the thing with Cassie. She's got endless energy. I think it's that department of energy that was referred to earlier. I'm very pleased that they don't know where she is, because I think they may actually utilize her to power the grid across Georgia. So yeah, and that is it. Cassie has. She's just dived in and is putting everything into their STEM curriculum at the elementary level. So yeah,
well, we're talking about Cassie, actually. She also did ask in the Q&A if there's any X chips that could potentially have a camera on them, or if we have any recommendations for a small camera that could withstand a at-home launch. I believe she's actually trying a weather balloon though, so a little bit less rigorous conditions, if you will.
Absolutely. Absolutely, you can. When Vincent refers to the using the Raspberry Pi and the Raspberry Pi interface, there are a number of teams who've used the Pi Zero, which is actually quite nice because it fits into like kind of like a 2-chip size, and can use that with cameras, a light, inexpensive cameras. Also, the flight hardware that Bjarke is building at the moment, on the core, there's going to be a camera connector interface thing. Sorry, I barely know how to spell hardware. So yes, that is definitely the plan, because that is what we all want, especially if we're doing a rocket project or high altitude balloon. We want to be able to see that atmosphere. We want to be able to see that it goes dark, above 15, 20 kilometers or whatever. Susie Cunningham is saying that she's used the kits in elementary student summer tech projects. Absolutely. So yeah, that's great.
Seeing if we missed anything here. Oh yeah, we do have another question from. I'm sorry.
Don't worry.
Dog, very angry. My apologies. Working from home.
No. Please don't worry.
Okay, so what type of limit on payload space / weight will we have? And that's a good question, actually. Do you mean for the suborbital launch or for like your at-home testing? I think that could potentially be different answers, right?
Okay, so I can answer that question in terms of the suborbital launch. What we've done is we've budgeted that per 1 CubeSat volume, 10 by 10 by 10 centimeters. We have budgeted that we will have 5 payloads in that area. So basically what you have is you have a cross section of 10 by 10 centimeters, which is exactly the 3 chips. This is actually 96 millimeters. So it's 3 by 3. And then you'll have up to 2 centimeters, 20 millimeters in depth or whatever. However, if you need more, let me know, because what I've done is that I've been very, very conservative with the number of payloads that we're going to have. And so the thing is that we actually do have additional volume. So if you do need more, then that's fine. Let's work it into the project. And the thing is that we have the flexibility because of our partnership with bluShift Aerospace. We certainly have that flexibility, where we can say, what we prefer to do is we prefer to have like 1 full U here, or 2 half U's here, or whatever it may be. Let's chat about it. If you need more volume, then you need more volume. From a mass perspective, we're looking at 200 grams for your payload. And I think that, and if that's not adequate, also once again, let us know. Because the general rule of thumb is for a CubeSat, for 1 U CubeSat, you get 1 liter and 1 kilogram. So that's why we can say maximum 200 grams. It's also swings and roundabouts, because a lot of them are going to be a lot lighter than that. So yeah, it's all swings and roundabouts.
Something I will note though too, for the model rockets that we're making specifically for the challenge, they will have a maximum payload of about 100 grams, and it will be like about a 36 millimeter diameter internal, and then there'll be about 5.5 inch tall payload base. So the kits that you'll be testing, or the like the same 4 chips or whatever that you'll be testing during your model rocket launch may not be the entire kit that you'll be testing on the suborbital launch, if that makes sense. So it'll kind of be like, you'll pick and choose your favorite couple of chips that you want to watch go up in your model rocket, and then you can add more to it later for the orbital launch, just because the payload capacity is significantly smaller. I'm sure you can understand on a model rocket compared to a 50-foot tall rocket. I think we've got a few more questions here, though. Do you plan to run a similar challenge again next year? Yes, I believe so. I think this is going to be a staple challenge, at least. And honestly, if anything, I'd like to add to it for next year. I'd like to have more requirements, not requirements, that's like gatekeeping requirements, but more things that your students can shoot for.
More
maybe
options.
Some other, right, exactly. Yeah. Thank you.
More options.
Another question, what should we make our frame out of? Or the sub.
I think a lot of people are going to be 3D printing their frames. So when we deliver the hardware to you as well, we'll have a session with how you can design your own frame and enclosure and things like that. So so definitely you can decide what you want your frame to be in. But at the moment, what we're looking at is that, especially for the suborbital launch, what we're going to be doing is we're going to be providing bluShift Aerospace with 3U volumes. So 30 centimeters by 10 by 10. They're getting 3U stacks from us. And so the thing is that all we're really expecting from you is your payload, the equivalent of 9 chips, and perhaps a 3D printed frame. But we're definitely going to be able to share a lot more of that once we need to bed down all of the integration requirements, and then we're certainly going to let you know. But it's not going to be something that's onerous. We're going to make sure that it's something that's really easy and inexpensive, because we don't want this suddenly to become a barrier.
Yeah. I think we could probably assist to some degree too. If there's schools who are really having an issue trying to figure something like this out, let us know. We can find a way to work around it or work through it, or one way or another.
Okay, Rena's asking suborbital with a question mark. Okay, so I think that was suborbital. So an orbital launch, actually, let's start with that. What the definition of an orbital launch? An orbital launch is where the rocket it'll launch, and then what needs to happen is that, apart from getting to the altitude, what you also need to do is that you have to have the speed. So you need to be able to get, what is it? It's over 20,000 kilometers per hour. I think it's something like 26 or 27,000 kilometers per hour, so that when the satellite is deployed, then it'll actually stay in orbit. Because what it needs to do is it has to have that velocity. Whereas a suborbital launch, the satellite and the rocket are not going into orbit. What it is it's basically an up and down. So the plan is that a little bit like a sounding rocket type project. So what will happen is that we'll have the launch. We'll go up. We'll definitely go beyond the Kármán line. So we'll definitely go into space, over 100 kilometers into space, and then come back down again. So at the top of the parabola, what is it called? There's a term for it. My mind's gone blank. We'll have 6 minutes of weightlessness. And that is why we're able to recover our payloads. And that's why we're able to get the payloads back to you, to get the data off the SD cards, etc. Is because it's not going into orbit, and it's fully recoverable. So Seth, I really hope I explained that properly. I mean,
next time
I'm gonna say, yeah, I'm a chemical engineer, so I can help you with chemical processes. But yeah, Rena, that's what it is. We got 6 minutes of weightlessness, and it's coming back down again. With this flight, it's not going into orbit per se.
We got a few more questions too. Two from Susie. One is, how and where can we purchase more weather balloons for testing purposes? Off the hand, I don't have an exact resource.
Okay. Yeah, absolutely. What I can do is I can send you a link. There are a number of sites that do sell them. What we do is that when we send up our balloon projects, we're not aiming at 30 kilometers or 100,000 feet or 90,000 feet. We're aiming more at sort of 15 kilometers. We have achieved a high altitude, but what we do is we buy very large party balloons. We buy 36, 38-inch party balloons and fill those with helium. Mike Galvin, I know that you purchased one of those really large white high altitude balloons. Fred Bruweiler, you know where to get the balloons as well. So maybe I'm sure we're going to be able to, amongst this group, we're going to be able to answer that question of where you buy it.
Maybe if the people who are familiar with that, if they could just maybe send us the links or either in the chat or to our emails, and we can pass it along to anybody who's interested. If you guys would be willing. Susie's also asking too, are there grants we can apply for? I'm sure there are, to be honest with you, and that's something that I'm working on now, is trying to go around, and I'd like to try to create almost like a list or curate basically a list, the best way to say it, of different grants that would be applicable to different situations, different schools, different demographics, a whole bunch of things. At this time, I don't have that off my hand, but I'm sure we could definitely do something about that. If you need funding for something, we could probably help you out.
Oh, absolutely. Yeah. There are a number of sponsors who really do want to sponsor. But the thing is, what's really important to them is that it's a group that is actually going to that's going to take that baton and is actually going to implement. So Susie, please pop us a mail. We've got some. Yeah, I think that's what we can do. We can definitely do something there. Yeah.
We have another question. What is the expected altitude for the first flight? And I will say we do have the bluShift boys in here. Maybe if they could give us a hand in the chat with the answer to that one, because I definitely do not have that off the top of my head.
Seth, can we promote you? I know this.
I think Seth and Sasha are under the same name right now, I believe. You might be sharing a phone or something.
Okay, there we go. Okay, there we go. I wonder, are you able to come in and answer that question? Great. Wonderful. Seth, thank you. Hello, good evening, good day. Good day.
Thank you. Thank you, and good evening.
Thank you for joining us, Seth. Absolutely.
My
if
pleasure.
You wouldn't mind just quickly also just introduce yourself.
Yeah, so I'm Seth Lockman. I'm the comms director at bluShift, and I am just thrilled to be a part of this webinar. I've been sitting here thinking about what things might have been like for me if I had had this opportunity as a student, and I never imagined I would get to play such a literal role in uplifting the next generation of STEM education. But this is just an amazing thing to be a part of. So thank you, Judy and Cody, for everything that MaxIQ is doing, and we're honored to be the delivery guys.
Well, thank you as well.
Absolutely,
we appreciate it.
Absolutely.
So the top question. Yeah.
What is the expected altitude? Actually,
yeah, from our end, the absolute minimum that we want to shoot for is 80 kilometers, which I believe is the minimum to qualify for NASA's Flight Opportunities Program, so that applicants can have their launch costs partially or totally offset by NASA. So that'll be a really big moment for us. Last I heard, we were actually going to shoot for 100, and that's just for the beta flight. And then once we go on to full commercial flights, then we want to be looking at 350 to 400 kilometers. So, almost up to basically where the ISS orbits. And that'll give people 6 to 8 minutes in microgravity. So it'll be something less than that for the beta flight.
Yeah, I must say I listened to a really interesting podcast by Neil deGrasse Tyson a few weeks ago, where he actually where he defines the Kármán line, and it's actually all about atmospheric pressure, not necessarily distance. It's the point. It's the estimated point at which one can see the stars during daylight, because there's there's so little scattering of the light, because the atmosphere is so thin that's so it's a theoretical point, and it depends very much on the season, whether that is 80 kilometers or 100 kilometers or even 110 kilometers. So that was quite interesting for me. So one always refers to the Kármán line, because the Earth's atmosphere does do this. And Seth, I'm wondering if you can answer Vincent's question, because he's saying in general for suborbital launches we have 3 minutes of 0G. What is special about the suborbital launch that has 6 minutes? So is there a way we can I don't know if Sasha explained it on Sunday, but I mean, I remember him mentioning that you were going to be able to achieve 6 minutes.
Yes, that is the goal. And that does have to do with our non-toxic rocket fuel and its performance in the hybrid engine that we designed. But fundamentally, the time in microgravity is a question of how high you can go and how fast you can go before the engine cuts out. So the long story short, we're going to go faster and higher than the competition, which is going to raise a number of technical issues around G-loading and heat management, particularly on the way down, which we think we've got a handle on. So we should be able to, by solving those issues, safely offer payloads almost double the time in microgravity. And that would be not necessarily from the moment that you reach space, but from the moment that the engines cut out. At that point, the payload and the rocket are both accelerating. They're still, the velocity is still very much upwards at that point, Mach 6 or so, but the acceleration is downwards. So they're going up at a decreasing rate, right? At the same rate. And so the rocket is no longer pushing on the payload. So the payload then experiences microgravity at some point in the upper atmosphere, up to space, and then on the way back down until air resistance starts to build up again.
Yeah, absolutely. So Dominic is concerned that we're all going to that all our payloads will get smashed to pieces on landing. No, because the main thing is that the rocket itself has to be recovered and reused. So, and our payloads are going to be inside of that. So that's
we'll return safely.
Yeah.
Hopefully, fingers crossed.
Touchdown at,
fingers,
10 miles an hour or less is very much the goal. Descent on parachute, splashdown in the North Atlantic.
Yeah, and that is also why we're going to have a data link, so that we're not all solely relying on being able to recover an SD card. We had a project last year where we had a kit that went to the International Space Station, and all of the kits on this particular mission needed to collect the data on the SD card, because we weren't given a data link. And something happened. There was a solar flare, and all the SD cards on that mission got corrupted. Nobody got any data, and so yeah, we can't do that to our students again. So Amina, I can see you here, and she was on that mission. Amina, it's not happening this time. Okay, you're getting your data.
Okay. We got another question, actually. I missed it. It was in the chat, and I just lost it again. But the question was, how do we go about obtaining the model rockets we were talking about earlier? And right now, I'm working with the manufacturers and the distributors. We're having them make us a few different prototypes. So we're going to test those first, see which ones we like best. Once we pick those, then we'll make them available to you guys. We'll definitely let you know when those are ready to go, but well before you guys would be needing to test your payloads, I believe, or at least right in time. You can see that also there's a link going around for, I believe, one of the weather balloons in the chat, if anybody is yet, from Mr. Mike Galvin, if anybody's interested in picking up one of those.
Great. And Vincent has also offered, Vincent has made an offer. He said, I've taught altitude determination to my summer school students. I'm more than happy to share my notes with everyone. That'll be fantastic. Altitude determination. Thank you. Great.
I missed anything.
Wonderful. Seth, anything else you'd like to share now that we have the group here?
Well, if I can plug bluShift a little bit, we're a couple weeks away from testing the engine that will power the rocket in flight, and we'll be live streaming that. So folks want to tune in. That should be pretty exciting.
That'll be fantastic. Thank you very much. That'll be absolutely wonderful. Thank you. Good. I think, Cody, I think we're done, aren't we?
All right. Yes.
I fear that we're going to miss a question. I don't think we're going to miss a question. I'm just going through them quickly to make sure we've covered all of them. Okay.
I just put mine and Judy's contact information in the chat again in case anybody missed the first time around. Again, if you guys think of anything, even 5 minutes from now, 5 days, 5 weeks, whatever, let us know. We'll definitely get an answer to you.
Absolutely. So yeah, so I think just to recap what the plan is. So yeah, to recap the plan, we're going to be sending kits out early February. Because of the chip shortage, we had to redesign one of the components, and Bianca was able to complete the code today, so that it'll run on all the components. So that's absolutely perfect. So now we can start getting those kits out, and then certainly we'll be able to get going. And even if you do have X chips, and even if you have had them for quite a while, you are so welcome to join the Getting Started sessions, because there's a lot more experiments that are available nowadays for those kits. For those of the XK01 starter kits, we've got a lot more experiments available. Got a lot more that we can do with it. You can use the soil moisture sensor with it as well. So yeah, quite a good idea to, if you want to, also to pitch up for those. It's all part of the program. So it's the more the merrier.
Actually, we got one more question. I kind of want to slip it in there. It's a good one from Dominique. And it says, will you be supporting us in getting FAA clearance to launch our tests? That's actually a great question. If you're going to do the model rockets, especially the model rockets that we're designing for the program, you actually won't need FAA clearance, just because they're not going to be going high enough. There is going to be restrictions, obviously, like you have to be X amount of feet from like an airport and a whole list of things that we'll definitely provide to you guys. But or at least for the model rockets that we'll be supplying or making available to you guys, you will not need clearance. If you do the weather balloon, I'm assuming you probably will need clearance.
No, really? No, most of the time it doesn't meet the weight threshold. It doesn't go over the weight threshold. But the thing is that there is a website, and what I can do is we've got like a pre-balloon mission checklist, and there's a website where you can actually check if you are allowed to launch in that area or not. You know, is it too close to an airport or maybe federal buildings or something like that? Or, you know, maybe an Army or Air Force base, something like that. So there are some areas where it is restricted, but the weather balloon payloads actually have to be large and heavy to require the license. But Seth, from your perspective,
sorry about that.
No, sorry. From your perspective, licensing, we're going to be doing that with you, because our payloads are not actually leaving the payload bay. We're not deploying them with this particular project. So we're going to be doing it all together, aren't we?
That's right. And I haven't been directly involved with the FAA permitting process, but I know we went through it with Stardust, and we're going to go through it with Starless Rogue, the beta flight and the full flights. And so I shouldn't say too much, but I would expect that we're probably, managing that, us and the FAA.
Yeah. Also, there's an amazing business. Mike Miller, he has Stirk Space, and they do a lot of the licensing for a lot of student satellites. They actually did all of the licensing for all of those ThinSats on the ThinSat program. So he knows a lot about doing this, and he's got very, very good relationships. And what we're actually aiming to do is to have a session with Mike so that he can say, before you even, if you're going to design, an orbital satellite, understand the restrictions first before you start designing your payload, so that you can make sure you don't go all the way down, designing and procuring and testing, and then suddenly you find out, oh, no, they're not going to let you fly that. So yeah, Mike is really amazing. So I can also share his details. But yeah, he's going to be one of those 18 guests that we're going to have.
Cassandra has a question for Seth, actually. Seth, when did you say that live stream will be for the engine test? Is it 2 weeks from now?
I would certainly hope. So we don't have a published date yet.
Okay.
Once we get notification from the engineers, we're 14 days out with high confidence. That's when we kick into gear. We'll make an announcement all across our social channels and website.
We'll of course share that with you guys as well too. So I'm sure once they sound the bell, we'll ring one too. So no one has to miss that or anything.
Thanks.
Great.
I think that's it. Unless I missed anything in the chat or anything.
Okay, Jennifer needed to go, and thank you, everyone.
That's it. Yeah.
This has really been great, and yeah, you've got our mails and everything else, and we'll probably have another catch-up call and a defined plan by the let's call it the 1st of February, because we're closing our manifest on the 31st of January. Good. I think with that, I'd like to say thank you very, very much to Cody for co-hosting me and scaffolding me through this process, and Seth, thank you very much for us dragging you in.
My pleasure.
Absolutely. And for everybody else, you have our contact details. Please, let's keep the open lines. And we are really looking forward to it next time. And Fred, thank you. I think what I'm going to do is I'll probably
next time, Fred.
Print a bow tie, and I'll put it in the package for Cody, so that he's suitably attired.
I got some options. I need some options. I only have the one. You guys got some extra bow ties you want to send around.
Wonderful.
Ask Judy for my address. Thank you, everybody. I really appreciate you stopping by.
Great. Thanks, everyone, and have a wonderful rest of your Thursday. Cheers.
Take care.